Welcome all to the course of Data Communication Networking, B7 semester, Electronics and Communication Engineering. We are discussing local area network unit. In the last session, we have discussed about the connecting LANs, in which we have discussed repeaters and bridges. In this session, we continue our discussion with connecting LANs, then go for a backbone networks, and after a virtual LANs. So a two-layer switch. When we use the term switch, we must be careful because a switch can mean two different things. We must clarify the term by adding the level at which the device operates. We can have two-layer switch or a three-layer switch. A three-layer switch is used at our network layer, and it is kind of a router. And the two-layer switch performs at the physical and the data link layer. So you have remember that we have seen a particular diagram for our different layer switches in our previous section. So over here a two-layer switch is there, so it is called as a bridges, and three-layer switch called as a router. Fine. So 1, 2, 3 layer is there. Over here 2 layer is there. Okay. So two-layer switch is a bridge. A bridge with many ports and design that allows a better or a faster performance. A bridge with a few ports can operate a few LANs together. A bridge with many ports may be able to allocate a unique ports to each station, with each station on its own independent entity. This means no competing traffic, no collision in our Ethernet. A two-layer switch as a bridge does make the filtering decision based on the MAC address of a frame it received. However, a two-layer switch can be more sophisticated. It can have a better to hold the frames for a processing. It can have a switching factors that forwards the frame faster. Some new two-layer switches called as cut-through switches have been designed to forward the frame as soon as they check the MAC address in the header of the frame. Okay, so it is a brief introduction of our two-layer switches or routers. A routers is a three-layer device that routes the packets based on their logical address, host-to-host addressing. A router normally connects a LANs and a WANs to the internet, and that has routing table that is used for making decision about the route. A routing table are normally dynamic and are updated using the routing protocols. We will discuss a routing in greater detail in a later chapter. Our figure shows the part of the internet that uses the routers to connect the LANs and WANs. Fine. So a symbol is for a router which connects a LAN and WAN to the internet. A three-layer switches. A three-layer switch is a router, but a faster and more sophisticated. The switching fabric in a three-layer switch allows faster table lookup and forwarding. We use the term router and the three-layer switch independently or interchangeably. Means router is called as a three-layer switch and three-layer switch called as a router. Next is gateway. Although some books may use a term gateway and a router interchangeably, most of the literature distinguishes between these two. A gateway is normally a computer that operates in all 5 layers of the internet or 7 layers of our OSI. A gateway takes an application message, reads it, and intercepts it. This means that it can be used as a connecting device between the two internet networks that use different models. For example, a network designed to use an OSI model can be connected to the another network using the internet model. A gateway connecting the two systems that can frame as it arrives from the first system, move it up to the OSI application layer, and remove the message. Our gateway can provide a security. We will learn that the gateway is used to filter the unwanted application layer messages. Fine, so it will be covered in later chapters. So next is a backbone networks. Some connecting devices discussed in this chapter can be used to connect a LANs in our backbone networks. A backbone network allows several LANs to be connected. In a backbone network, no station is directly connected to the backbone. The stations are a part of a LAN and the backbone connects the LANs. Backbone is itself a LAN that uses a LAN protocol such as Ethernet. Each connection to the backbone is itself another LAN. Although many different architecture can be used for the backbone, we discuss only two most common, just like our bus backbone and star backbone. Fine. So in this topic, bus backbone, star backbone, and connecting remote LANs will be discussed in this backbone networks. So start with our bus backbone. In a bus backbone, the topology of the backbone is a bus. The backbone itself can use one of the protocols that supports a bus topology, such as our 10-base-5 or 10-base-2. So we can say that in a bus backbone, the topology of the backbone is a bus. A bus backbones are normally used as a distributed backbone to connect different buildings in an organization. Each building can comprise either a single LAN or another backbone, normally is a star backbone. A good example of a bus backbone is one that connects a single or a multiple floor buildings on a campus. Each single floor building usually has a single LAN. Each multiple floor building has a backbone, usually a star, that connects each LAN on the floor. A bus backbone can interconnect these LANs and backbones. So this figure shows an example of a bridge based backbone with our 4 LANs, 1, 2, 3, 4. A bridge is there. In this figure, if a situation in a LAN needs to send a frame to another situation or a station in the same LAN, a corresponding bridge blocks the frame. The frame never reaches the backbone. However, if a station needs to send a frame to the station in another LAN, the bridge passes the frame to the backbone, and which is received by the appropriate bridges and delivered to the destination LAN. Each bridge connects to the backbone has a table that shows the station on the LAN's side of the bridge. The blocking or a delivery of the frame is based on the contents of this table. Next is star backbone. In a star backbone, sometimes called a collapsed or a switched backbone, the topology of the backbone is a star. In this configuration, the backbone is just one switch. that connects a lens. That's why it is called as an erroneously a collapsed backbone. So, in a star backbone, the topology of the backbone is star. The backbone is just one switch. As you can see in this figure, a star backbone, note that in this configuration, the switch does the job of the backbone at the same time it connects the LAN. Fine? So, a dual purpose is there. A star backbone are mostly used as a distributed backbone inside a building. In a multi-floor building, we usually find one LAN that serves each particular floor. A star backbone connects these LANs. The backbone network, which is just a switch, can be installed in the basement of the first floor, or the separate cable can run from the switch to the each LAN. If the individual LAN have a physical star topology, either the hub or a switch can be installed in the closest of the corresponding floor, or all can be installed close to the switch. We often find a rack or a chassis in the basement where a backbone switch and all hubs or a switch are installed. Next is how to connect our remote LANs. So another common application of a backbone network is to connect a remote LAN. This type of backbone network is useful when a company has several offices with a LANs and need to connect them. The connection can be done through the bridges, sometimes called as remote bridges. Fine. So you can see this. The bridges act as a connecting device, connecting the LANs and point-to-point networks such as leased telephone lines or ADSL lines. The point-to-point network in this case is considered a LAN without stations. The point-to-point link can use a protocol such as PPP. Our figure shows a backbone connecting our remote LANs. So we can say that our point-to-point link acts as a LAN in a remote backbone connected by our remote bridges, as you can see over here. Fine. So it is how to connect our various LANs remotely. Next point is virtual LANs. A station is considered a part of the LAN if the physically belongs to that LAN only. The criterion of membership is geographic. What happens if we need a virtual connection between two stations belonging to the two different physical LANs? We can roughly define a virtual local area network called as a VLAN as a local area network configured by the software, not by the physical wiring. Fine. So over here a software is there. Over this period or in this topic, following topic to be discussed in this section. Let us examine or let's have an example to elaborate this definition. Our figure shows a switched LAN in an engineering firm in which 10 stations are grouped in 3 LANs that are connected by the switch. The first 4 engineers work together as the first group, the next 3 engineers work together as a second group, and last 3 engineers work together as a third group. The LAN is configured to allow this arrangement. But what would happen if the administrator needs to move 2 engineers from the first group to the third group to speed up the project being done by the third group? The LAN configuration would need to change. The network technician must be rewired. The problem is repeated if in the another week the 2 engineers move back to this previous group. In a switched LAN, changes in the work group mean physical changes in the network configuration. Fine. So this figure shows the same switched LAN divided into the VLANs, means virtual LANs. The whole idea of a virtual LAN technology is divide a LAN into a logical instead of physical, just like our segment. A LAN can be divided into the several logical LANs called as an VLANs over here. Fine. Each VLAN is work group in an organization. If a person moves from one group to the another, there is no need to change the physical configuration. The group membership in the VLAN is defined by the software, not the hardware. Any station can be logically moved to the another VLAN. All members belonging to the VLAN can receive the broadcast message sent to that particular VLAN. This means that if a station moves from VLAN 1 to VLAN 2, it receives the broadcast message sent to the VLAN, but no longer receives the broadcast message sent to V1 or VLAN 1. It is obvious that the problem in our previous example can easily be solved by using the VLANs. Moving engineer from one group to the another group through the software is easier than changing the configuration of our physical network. VLAN technology even allows the grouping of a station connected to the different switches in a VLAN. Fine. So you can see this. It shows a backbone local area network with two different switches and 3 VLANs. Station from the switches A and B belong to the VLAN. Fine. This is a good configuration for a company with 2 separate bridges or buildings. Each building can have its own switch LAN connected by the backbone. People in the first building and people in the second building can be in the same work group even though they are connected to the different LANs. From these 3 examples, we can define the VLAN characteristics that VLAN create a broadcast domains. VLAN groups stations belonging to the one or more physical LANs into the broadcast domains. The stations in the VLAN communicate with one another as though they belonging to the physical segment. Next is membership. What characteristics can be used to group a station in a VLAN? Vendor uses different characteristics such as port number, MAC address, IP address, IP multicast address, or a combination of 2 or more these. So let's define each one. Port number. Some VLAN vendor uses switch port numbers as a membership characteristics. For example, the administrator can define the station connected to the ports 1, 2, 3 and 7 belonging to the VLAN. As you can see, fine. Station connecting to the port 4, 10 and 12 belonging to the VLAN 2 and so on. Next is MAC address. Some VLAN vendor uses a 48-bit MAC address as a membership characteristics. For example, an administrator can stipulate that the station having a MAC address as E21342A 12334 and F2A 123 BCD 341 belong to the LAN 1. So it is a one type of MAC address. Third is IP address. Some VLAN vendor uses a 32-bit IP address as a membership characteristics. Multicast IP addresses. Some VLAN vendor uses a multicast IP address as a membership characteristics. Multicasting at the IP layer is now translated to the multicasting at the data link layer. Lastly, a combination. Recently, the software available from the one vendor allows all these characteristics to be combined. the administrator can choose one or more characteristics when installing the software. In addition, the software can be reconfigured to change the setting. Okay, let's go ahead. A configuration. How are the station grouped into the different VLANs? Station are configured in one of the three ways, just like our manual, automatic, or semi-automatic. So first, what is a manual configuration? In the manual configuration, the network administrator uses the VLAN software to manually assign the station into the different VLANs at a setup. Later migration from the one LAN to the another LAN is also done by manually. Note that this is not a physical configuration, it is a logical configuration. The term manually here means that our administrator types the port number, the IP address, and other characteristics using the VLAN software. Second is automatic configuration. In an automatic configuration, our stations are automatically connected or disconnected from the VLANs using a criteria defined by the administrator. For example, the administrator can define a projector or a project number as a criteria for our being a member of a group. When a user changes the project, he or she automatically migrates to the new VLAN. Fine. So in a semi-automatic configuration, software have been used for anything, sometimes somewhere between the manual configuration or automatic configuration. Usually the initializing is done manually with the migrants done automatically. Fine. So it will call as a semi-automatic. So how to communicate between the switches? In a multi-switch backbone, each switch must know not only which station belong to the which LAN, VLAN, but also a membership of a station connected to the other switches. For example, our 17 number figure, yes, a switch A must know the membership status of a stations connected to the switch B, and switch B must know the same about switch A. Three methods have been devised for this purpose. So it can listed over here: a table maintenance, a time tagging, and a time division multiplexing. In the first, a table maintenance method, when a station sends a broadcast frame to its group member, the switch creates an entry in the table and records the station membership. Switches send their tables to the another periodically for updating. Second is frame tagging. In this method, when a frame is traveling between the switches, an extra header is added to the MAC frame to define the destination VLAN. The frame tag is used by receiving switches to determine the VLAN to be receiving the broadcast message. Last, our time division multiplexing or TDM. In this method, a connection between switches is divided into the time shared channel. For example, if a total number of VLANs in a backbone is 5, each trunk is divided into 5 channels. The traffic designed for the VLAN 1 travels in the channel 1, the traffic designed for the VLAN 2 travels in the channel 2, and so on. The receiving switch determines the destination VLAN by checking the channel from which the frame arrives. Fine. So it is our communication between switches. Next is an IEEE standards used for that purpose. In 1996, an IEEE 802.1 subcommittee passed a standard called as an 8021Q that defines the format for a frame tagging. The standard also defines the format to be used in a multi-switch backbone and enables the use of multi-vendor equipment in a VLANs. IEEE 802.1Q has opened the way for a future standardization in other issues related to the VLANs. Most vendors have already accepted the standard. Fine. So standard use for this IEEE 802.1Q. So what are the advantages of our VLANs? So there are several advantages using the VLANs. We have listed most important advantage of the same. First is cost and time reduction. VLANs can reduce the migration cost of a station going from one group to the another. Physical reconfiguration can take time and it is costly. Instead of physically moving one station to the another segment or even to the another switch, it is much easier and quicker to move by using our software. Second is creating a virtual work group. VLAN can be used to create a virtual work group. For an example, if in a campus environment, professor working on the same project can send a broadcast message to one another without the necessity of belonging to the same department. This can reduce the traffic if the multicasting capacity or capability of an IP was previously used. Lastly, and security. A VLAN provides an extra measure of a security. People belonging to the same group can send a broadcast message with a guaranteed assurance that users in the other group will not receive this message. Fine. So security concern will be there. Okay. It is the end of our session. Let's revise our discussion. Yes, we started our discussion with our two-layer switch and routers. A router is connecting devices for a LAN and WAN to the internet. A gateway and three-layer switches. After we introduce a backbone network in which bus and star backbone is discussed deeply. It is a bus backbone, it is a star backbone. Connecting a remote LANs with a bridge we have discussed. After that, we introduce a virtual LANs. We have defined 3 LANs with the help of the physical link. Then it's a solution of our virtual software LAN. 2 switches in a backbone using a VLAN software. How to identify a membership with the following characteristics: port number, MAC address, IP address, multicast address, or a combination of 2 or more. How to configure our virtual LANs: manual, automatic, and semi-automate. How to connect or communicate between the switches by the table maintenance, frame tagging, and TDM. A particular standard used for our virtual LAN is 802.1Q is there. And advantages of our virtual LAN. So it is the end of our session. Following questions for you, write down in your notebook and send back it to me as per the given direction. Comment if any query. Okay students, see you in the next session. Thank you.